Okay, so this video is going to go through sketching quartics, and a quartic is some polynomial with the highest power is 4, so it has x to the power 4 plus some other terms. Okay, and in general it looks like this. It looks like a more stretched out parabola, a positive quartic, or it looks like a W, depending on its factors. Okay, this one has this sort of general form which looks like your turning point form for a quadratic. Same with this one, except it's a negative, so it's like a negative kind of U kind of shape, and a negative quartic looks like an M. Alright, so steps of solving a polynomial. First you should name it. Okay, what is it? Is it a cubic, a quartic, a quintic, a linear, whatever? So identify the shape as negative or positive. Look at the x-intercepts, so you need to factorize there, or get it in factorized form to get your polynomial to look something like this, and so on, whatever it is. And the type of x-intercepts. So remember, if you had a polynomial, okay, if you had a cubic and you had x minus 2 squared times x minus 1, the powers determine what happens at the x-intercepts. So if you have an even power, that implies it touches the x-axis. Touches. And if you have this, sorry about that, sort of invisible power of 1 here, or an odd power, it cuts through the x-axis. So that's going to be important when we get to sketches. So just a very quick example, and trying to use this program to make it look nice. If you ask to sketch this quartic, it's kind of in our turning point form already. So what you would do is, okay, it's a quartic, so it's a more fat kind of parabola. Turning point at 2, negative 1, just the same as quadratics. Okay, 2 to the right, 1 down. You would then identify if there's going to be any x-intercepts. Well, it's been transformed from sort of this standard one to 2 to the right and 1 down, so it will have some x-intercepts. So you solve for them, making y equal to 0, do your algebra, add 1 both sides, take the 4th root both sides. Okay, how would we do that in a calculator? I'll bring it up in a moment. But by hand, the 4th root of 1, what number multiplied by itself 4 times gives you 1? The answer is 1. And then you get 1 equals x minus 2. Oh, sorry, plus or minus 1. So there's 2 numbers there. Plus 1 times plus 1 times plus 1 times plus 1 will give you 1. And negative 1 times negative 1 times negative 1 times negative 1 will also give you 1. So you get those 2 solutions you must account for. Add 2 to both sides and you get those are the x-intercepts. Easily find the y-intercept by making x equal to 0. And then you have negative 2 to the power of 4, which means negative 2 times negative 2 times negative 2 times negative 2, which gives you positive 16, minus 1 gives you 15. So then I have my general shape, I can just sketch it. So that's the first, by hand quartic sketching example. The next one would be similar. You have this 2 to the right thing happening and 3 up, so there could be no x-intercepts. So you just simply solve for the y-intercept and do your sketch, and make sure you label this point of minimum point. Okay. Now what about this one? What would that one look like? We have x squared minus 3 times x minus 4 times x plus 8. So what happens is if you expand these brackets, you get x cubed times x plus 8. And then when you expand that, you get x cubed times x, which gives you x to the 4. So these multiplications of the x's gives you a quartic, and it's a positive quartic, so it's got this W shape. And you'll notice that I could sort of factorize a bit further. This one here could be factorized to be using my difference of perfect squares. If I force 3 to be root 3 squared, then I've got a difference of perfect squares there. And we get x minus root 3 times x plus root 3. Okay, and so that's a quartic that goes through root 3, negative root 3, 4, and negative 8, because the way you get the x-intercepts is you make y equal to 0, which means that x minus root 3 is 0, or x plus root 3 is 0, and so on. So x is root 3, or x is negative root 3, or x is 4, or x is negative 8. So what's my quartic going to look like? Well, I know it goes through negative 8. I know it goes through negative root 3. I can find the y-intercept is 96 by making x equal to 0 here. You get root 3 times root 3 is 3 times 4 is 12 times 8 is 96, and you have to take care of the negatives and stuff. And then it goes through positive root 3 and then through root 4. And I know it's got like these little powers, positive 1 here. So I know it cuts through. I know the general shape looks like this, so it just sort of goes all the way, looks like a W. And that's my sketch. You can't find minimums or maximums with quartics unless you know calculus or use your calculator. And it's definitely not the average of the x-intercepts like it is with quadratics. It just doesn't work like that. So don't assume that you can find these maximum or minimum turning points, and in fact it's a waste of time if you are trying to do that. Okay, so let's just look at some other quartics and see what they look like. Okay, so if I put y equals x minus 2 squared, that gives me like quadratic, and then I times it by x plus 2 squared. You see what I get here? I get that sort of W shape, and it touches at negative 2 and positive 2. Alright, what if I changed it to be x plus 2 no power times by x minus 1? What's going to happen? Well, it should touch at positive 2, it should go through negative 2, it should go through positive 1. Oops. Come on. There we go. So what does it look like? Still got that sort of W shape, but you've got it touching at positive 2, you've got it cutting through at negative 2, and you've got it cutting through at positive 1 there. Okay. What happens if I make, this guy negative? It swaps the direction, so you get this sort of M kind of shape happening. Alright. What happens if I put a negative inside this brackets? Will it become a positive or a negative quartic? Let's just see. It's still positive. It still has this kind of W kind of shape. And the reason for that is that when you expand this bracket, you get a positive x squared. Multiplying by this x gives you a positive x to the 4. So you still have this kind of W shape, but it changes the x-intercept because, you know, making this guy equal to 0 using the null factor law, what has to be here in order to make this whole bracket 0? It has to be -2. -2 gives you +2, -2 is 0, which gives you the y is 0, which gives you that. So basically quartics are just an extension of what we've learnt with cubics, and you must know the shape, the general shape of a quartic. You must know what an even power does. It makes it, you know, touch, whereas an odd power makes it cut. And you know how to find x-intercepts and y-intercepts. Let's just do one more and see what happens. X minus 2 cubed times by x plus 2. Okay, so what happens there? Again, you get this kind of, you know, W shape, but if you have a cube here, it doesn't just cut straight through, right? It does this sort of curvy cut. It goes kind of like, you know, your normal kind of cubic. So you have to be careful, you know, if it's to the power of 1, then it cuts straight through. Make it a different number. See, this to the power of 1 cuts straight through x is 2. This square makes it touch, and this has a power of 1 here at -3, so it goes straight through. But again, if I make it a cubic, right, at x equals 2, you get that kind of curvy cut. So that's something to keep in mind as well. And that's it.